Hello guys, I'm the guest today. My name is Pepe, the Chef Rock. I want to learn about cryptocurrency because I'm broke. About cryptocurrency, today we will learn about symmetric and asymmetric cryptocurrency, hashing, application of encryption, and AES. The resource I've used to research these came from Wikipedia. So, oh shit, muscle memory. Wikipedia. And with symmetric and asymmetric, I have two pictures here that represent the whole encryption and decrypt. With symmetric, you will have the same key to encrypt the plain text and decrypt the ciphertext. There's a lot of standard for the encryption algorithm, and the other one is asymmetric encryption. They have two keys and one to encrypt. As you see in the picture, it is a public key and a private key that decrypt the ciphertext. This is real practical use of asymmetric encryption on the internet because they encrypt your password and your text message through the internet. And with symmetric, we have Bullfish, AES, RC4, DES, RC5, and RC6 as widely used symmetric encryption. With DES is a very old standard, and people now move to AES as it is more secure. With asymmetric, we have a lot more, which is RSA and DSA, ecliptic curve techniques, PKCS are among the best way of encrypt standard, and they all have benefits and drawbacks. With symmetrics, they are fast, however they are vulnerability to attacks because they use the same key. If someone on the internet can smurf your key and they can easily access to your data. With asymmetric encryption, you are much safer as there are two kind of different keys, so it is harder. Although if the hacker they snuff your key, they will still know a part of the key. And yeah, let's move to hashing. Hashing is actually a mathematical function that transfer text into some digit code. With this example, you can see that Fox is encrypted into a bunch of hash and code. These they are very different from each other. However, with one input and with the same hashing method, there will be only one ciphertext, and even if the input is changed a little bit, the digit will be completely different. And you can see that length doesn't matter, because even though the length is different, like this fox only have 3 digits, however there's a sentence, they still generate with the same hash function. They will always generate the same amount of digits. Here's the common hashing method. MD5 is widely used in the past, however it is obsolete now, and also it is insecure now if you use MD5 to encrypt your data, because they have a table that map all of the hash code that have a lot of people use it to make their password, so they can crack your password if you use MD5 to encrypt your data. However, with SHA-2, it is much more secure, as it has a lot of kind of other way of encryption. And SHA-2 is now the standard. And the more digits they have, the harder to crack. And they represent the size of the key and the ciphertext also. So with SHA-224 is 224 bits, and so on to SHA-512 bits. There's a lot of implement with hashing, which also include hash table, cryptography, blockchain. Now let's move on to AES. AES is a symmetric encryption, and it is our standard for today encryption, as it is really hard to brute force. It would take 1 billion years to brute force AES 128 bits key length, so it is impossible for any kind of machine to brute force it. A lot of people would ask, why don't we make the key length longer? However, if you make the key longer, it will sacrifice a lot on speed, and you don't want to be sending an email and waiting for an hour just to send it, just to encrypt and decrypt the data. So AES is a balance of speed and security. So thank you for your listening, and Pepe's out. Peace.